Okay, I'm sure everybody's interested to see this little experiment. So what I'm using is one of my old coils I used in my previous generator, but this is a coil I use as the pulse drive coil. Now you'll find this quite interesting because the amount of drag is virtually minimal. Now remember that we're driving this with a CD-ROM motor. It's a tiny little thing, it doesn't have a lot of torque, and I lost a lot of RPM because of my changes I made to the coil, compressing the coils. In the previous live stream I was explaining how I compressed the coils. Well, I actually lost more than 50 RPM actually. I think more like 100 actually, maybe more than that. Anyway, this is where we're at the moment. We're at 1172 RPM. Now, I've got the meter set to 200 milliamp range. I'm going to turn that on, and it's across the coil. So what this experiment is about, I'll put the meter on here, just a minute. This experiment is to show how much the rotor slows down, short-circuited through this coil. Sorry, the coil is short-circuited, and we're going to put it near the segments which reduce the drag effects. So, right, let me just try and show you what this. You'll find this really interesting. So our RPM at the moment is 1175, and look at that, it's picking up power even from this distance. That's how far that field comes out. Now let's start bringing the coil closer to the actual rotor assembly. Look at that current. Look at the current it's consuming. We're at 70 milliamps. Look at our RPM. It's hardly dropping. Right, let's bring it a bit closer. We're over 100 milliamps. We're drawing 100 milliamps RPM. It's hardly dropping. It's dropping very slowly. Normally you would expect it to drop like a stone with that amount of load on it. We're still at about 9900 milliamps. I'm trying to keep my hands still. See, 11. It's barely dropping, right? We're still at 94 milliamps. I've just got the coil over the rotor assembly as it's spinning. I've got one core in there at the moment. 94 milliamps. So how much does the coil produce in voltage? Well, it's about 0.6 volts. It's only about half a volt. Look at that RPM. That's barely dropped. And 91 milliamps. Let's just go to voltage. I'm going to put this down a minute. I don't want to drop it on the floor because. Hang on a minute. Right, we're on AC volts, and the voltage is about 0.33 volts at that distance. Right. If I get closer, it'll go up to. If I get closer to the middle of the field, it's about half a volt. Right. So I wanted to give you some comparatives to look at. My meter's been acting up because the ratchet underneath wants fixing. I need to sort that out because sometimes my knob gets stuck. Right, we're back on 200 milliamp range. Right. Bring the coil closer. 100, let's bring it right in the middle. 136 milliamps, 137 milliamps RPM. It's not dropping much at all. It has negligible effect on it, so obviously there's more tweaking to do. But I thought you'd find this little probe test that's what this is basically. We're using a coil as a probe. Coil 100. We're pulling at 119 milliamps at the moment. It's settled around 1100. 36. About 100 milliamps. There you go. So that's what I'm doing. Doing some tests to find the optimum. Now the segments on the other side are less efficient. So if I go to the segments I haven't upgraded yet, look at that. Let's look at the difference. Look at that. That's all the current I'm getting out. That rotor on the back side, the one I haven't repopulated with the new segments yet. That rotor on that side, we're only getting 37 milliamps out of it. That's on that side. Now if I bring it across, let me back out so you can see the meter. If I bring it across, look at that in the middle, 100 milliamps in the middle rotor. Let's go across to this side. We're still at 109 milliamps on this side of the rotor, which has got the new segments in it. The middle rotor, 105 milliamps. The one that hasn't been done yet, it drops down to 36. So that's a good little probe test. And I wanted to share that with you because I did that yesterday and I thought I need to live stream this. I've done it and showed you it, and seeing is believing. Right, thank you for watching. Bye for now.